So in this lesson, we've learned the derivative of sine of x is cosine of x. We learned the derivative of cosine of x is negative sine of x. We learned the derivative of e to the x is itself e to the x. And we learned the derivative of the natural log of x is 1 over x. So we can use those rules or those statements and we can combine them with the other things we've learned, and we can build all kinds of fascinating functions and take their derivatives quickly using the derivative rules we've learned over the last 2 or 3 lessons here. So let's consider f of x equal to e to the x over 2 plus x cubed minus 4 over x squared plus the natural log of x. And I want to find f prime of x. So that's a very wild function, but we can do this. We have our properties and our rules that are going to let us take this derivative. So I'm going to do just a couple of rewrites here for f of x before I take its derivative. So notice that my notation still says f of x equals. I have not taken the derivative yet. E to the x over 2, just kind of a reminder, that's really the algebraic rewrite for that is going to be 1/2 e to the x. And that way I can say, okay, 1/2 is my constant. I know what to do with it, and then I'll focus on the derivative of e to the x. That kind of clears up any ambiguity there. So that's a perfectly fine way to rewrite that so that you can kind of see the pieces here. X cubed is good. We're going to know exactly how to take the derivative of it. If I look at 4 over x squared, hopefully by now we've picked up on the idea that if I have x in the denominator, that I want to rewrite that as a negative exponent. So that's minus 4x to the minus 2. And then the natural log of x, we know its derivative, so we'll apply it here in just a moment. So this was all about me writing f of x in a way that kind of just sets it on the tee for me to hit this out of the park and take its derivative. So now I can say f prime of x is equal to, well, 1/2, the derivative of e to the x, remember, is just e to the x. So this is 1/2 e to the x. Derivative of x cubed, we know, is 3x squared. For this derivative right here, I know negative 2 is going to multiply by negative 4, and that's going to become plus 8x. Remember to reduce the power by 1. Negative 2 minus 1 is negative 3. And then the derivative of natural log of x is plus 1 over x. So there's the process which I used all the derivative rules we've learned so far. Now then, if I take my, just kind of cleaning this up, so f prime of x is equal to, e to the x, I can put it back over 2. So e to the x over 2 plus 3x squared is fine. I do want to clean up my negative exponent, so that's going to be plus 8 over x cubed, and then plus 1 over x, just like that. So now let's look at one more function right here. Let's consider the function g of x equal to 4 times x squared minus the cosine of x plus the natural log of x. And I want to find g prime of x. Well, one of the things we know we're going to have to do is we're going to have to get it into this where I can look at one piece plus or minus another piece. I need to use that sum or difference rule. So I need to take this 4 and I need to go ahead and distribute it to each piece so that I can kind of get it into this form where I can really break it down piece by piece. So let's distribute that 4 and get g of x equals 4x squared minus 4 times the cosine of x plus 4 times the natural log of x. Now I can take its derivative pretty quickly. So this is g prime of x equals, well, 4x squared, its derivative, 2 times 4 is 8, x to the 1 power, minus 4 cosine of x. That's going to be minus 4. And then the derivative of cosine, remember, is negative sine of x. So that's actually going to change this minus to a plus, and then it'll be plus 4 times the sine of x. So that's where the derivative of cosine becomes negative sine. And then for 4 natural log of x, I know that's going to be 4 over x. 4 times 1 over x, or 4 over x. And so there's my derivative right there. I've already done it, and I don't really need to clean that up anywhere. I don't have any negative exponents to address or anything like that. So there's g prime of x. And hopefully over the last 3 lessons here, where we looked at the power rule. We looked at our sums, differences, constants, and constant multiples. And now we throw in the functions sine, cosine, e to the x, and natural log of x. Hopefully you can see that taking derivatives is a relatively easy process once you understand how the rules work and how to use them. Taking the derivative is normally just a 1 or 2, sometimes 3 steps if you have to do some rewriting kind of process. But it is a pretty simple process in calculus, and it's really important that you be able to take the derivative of any function that's given to you, because that's really what we're going to focus on working on in units 3, 4, and 5 in particular. But it really is a main idea of calculus that you be able to take a derivative quickly and efficiently.